Hi, Assalamualaikum. In this video, we will learn about the simultaneous equations in three variables. Right, before this, we have learned about the simultaneous equations in two variables, but now we are going to look at the equations with three variables. Suppose we have x, y, and z for the first question here. Right, so what we do firstly is to label each equation with the number, right? So 1 to equation 2 and equation 3. Right, the idea is to reduce, right, from three variables. We are going to make, right, from three equations, then we are going to reduce this into two variables. Meaning to say that we have to eliminate one of these variable. It's either you want to eliminate x, eliminate y, or eliminate z. All right, suppose in this case, all right, let's say I want to eliminate y. All right, let's say I want to eliminate y. So how to eliminate y? So of course, to solve the equation with two variables, we need to find the two equations here, right? So we have to get the two equations. This is our aim, all right? So how to do that? All right, suppose I want to eliminate y, meaning to say that, right, so let's say the first one is I just add 1 with 2, all right? When I add the equation 1 with equation 2, therefore I have, all right, so x plus with 2x, all right, so I have 3x because these two has been eliminated, all right? So I have 3x plus with 6z, all right, this one is actually equal to 24. Right, this is the first equation for the equation with two variables, all right? So next, I need to make something with the, let's say, the first equation. Let's say I just want to do something with the first equation with the the equation 3, right? Right, so but to do that, we have to modify equation 3 so that when we to eliminate y, we have to make the coefficient the same. In this case, we don't have the same coefficient of y, therefore we have to find another equation. Let's say I multiply the third equation, right? So let me just write the third equation is multiplied by 3, so I have 9x, because everything here should be multiplied with 3, right? Because we multiply with 3. Right now, we have minus 3y plus 3z equal to 27. So this is the fourth equation, all right? So try to imagine the first equation. Now, we add with the fourth equation, 1 plus with 4. Right, so we need to consider this equation, right? So this equation, also this one. When we add them together, right, so we know that 3y add with negative 3y, it will become 0. So we are left with the x and 9x. So x plus 9x, we get 10x. 4z plus 3z, we get 7z, right? 7z, which is equal to, right, 14 with 27. So of course, we'll get 61, no, 41, right? 41. Okay, that one is 30, that one should be 41. Right, now when you have this one, right, you have, now you have the, right, now I'm gonna write this, right, this is, right, let me highlight this, all right, better highlight this, right? So now we have the equation in variable x and z, all right? So we have to solve these simultaneous equations, meaning to say that we have to solve these two equations simultaneously, right? To solve these equations, so how to solve this, we have seen in the first video, right? All right. So now, to solve this, you can use either elimination or substitution. If you want to use the elimination, then I'm gonna write it in some, suppose to make the, suppose I want to eliminate x, therefore I have to multiply the first equation here with 10, therefore I have 60z equal to 240, and then the second equation should be multiplied with the constant 3, and therefore I have 30x plus with 21z, and then this one equal 41 multiplied by 3 should be 123, right? So this is the first equation now, this is the first one, and this is the second one in this case, all right? Because we are going to solve the, what do we call, simultaneous equations in two variables. So to eliminate x, of course, I have to use minus here. So 30x minus 30x will get 0. 60 minus 21, so we'll get, all right, 60 minus 21 will get 39z, right? And this is actually 240 minus 123. I've got 117. Therefore, the value for z is actually 117 divided by 39. It's actually 3. Right? So we got the value for z. All right. So let me highlight the first equation for the first answer that we've got. Z is equal to 3. Right now, what we need to do is to find the value for x. So I can make use of the first equation here. So I have 3x plus 6z, right? And let me just write the first equation is equal to 24. But since we have already obtained the value for z, so 3x plus with 6 multiplied with 3 equal to 24. Therefore, 3x plus with 18 equal to 24. Therefore, 3x equal to 24 minus 18. I've got 3x, which is equal to 6. Therefore, x is actually equal to 2. All right? That's all right. X is equal to 2. Okay, x equal to 2. So I've obtained the second answer here. But now to find the value for y, you can actually substitute the value of x and z inside any of these equations. All right? So suppose I substitute it inside the the third equation. All right? So substitute. Let me just write substitute x equal to 2 and z equal to 3 into equation number 3. Therefore, I have alright, 3x is actually equal to 2. 3 multiplied by 2 minus y plus with z is actually 3 equal to 9. Therefore, 6 minus y plus 3 equal to 9. So negative y equal to 9 minus 3 minus 6, right? So that one is actually 0. So negative y equal to 0. So of course y should be also equal to 0. So now I have obtained the value for y. In this case, we have already obtained the value for x, y, and also z. So we already solved these simultaneous equations. Right, let's now move to the second example here. All right. If suppose we have these three equations, the equations in three variables, where we need to solve it simultaneously. Firstly, we need to label so that it's easy for us to make clear on solving these type of equations. So what we do first, in the first step, always we want to eliminate something, a variable. All right, you can choose any variable you like actually. Right, suppose I want to eliminate x in this case. All right, so what I do is actually, suppose all right, 2 minus 1, because I want to eliminate x. Right, so 2 minus 1, meaning that x minus x will be 0, y minus negative y, right? So y minus negative y will give me 2y, all right? 2z minus a negative z will give me positive 3z, right? And then I have 3 minus negative 9 will be actually 12. All right. So that is 2 minus 1. Right. Now, what I'm going to do is actually, all right, to find another equation. All right. So I can choose any, but because we have already eliminated x in the first equation, so of course we have to do the same thing for the second one. Right. So to do that, we have to actually multiply first. All right, suppose I want to relate equation 3 and 2, but to eliminate x, so the coefficient should be the same. So this is 2 and that is 1, but to make it the same now, we have to multiply the second equation. All right, so the second equation should be multiplied with 2, so that we have actually 2x plus 2y plus 4z equal to 6. Therefore, what I do is actually, this is equation number 4, all right? And then what I do is all right, because equation number 4 is from 2, so I want to do something equation 3 and 4 actually. Right? Please note that I'm going to relate equation 3 and 4. So if you're not clear, then let me just write equation 3. All right? 2x plus 2y plus z equal to 0. Right, so this is equation number 3. So what can we do to eliminate x from equation number 4 and 3? So we can actually subtract 3 from equation number 4. So 4 minus 3, in this case 4 minus 3 will be, all right, 2y minus 2y is 0 also, and then we have actually 3z, all right, 4z minus z will give us 3z is actually equal to 6 minus 0 will be 6. Z is actually equal to 2. So, all right, we should have obtained, all right, the two equations, but in this case we have reduced to one variable only, so we already obtained the value for z is equal to 2. To find the value for y, we need to substitute inside this equation. All right, right, let's see. Let me label this equation number 5, suppose. Right, so we have x equal to 2, z is equal to 2. We need to substitute the value z equal to 2 into equation number 5 so that we obtain the value for y. Right, so let me just write substitute z equal to 2 into equation number 5. All right, therefore I have, all right, 2y plus with 3z. Z is actually 2 equal to 12. Right, so 2y plus with 6 equal to 12. Therefore, I have 2y, which is equal to 12 minus 6. 2y is actually equal to 6. Therefore, y equal to 6 divided by 2. I have y equal to 3. So now I've obtained the second answer. Y equal to 3 and z is equal to 2. To find the value of x, we can actually substitute inside any of these equations 1, 2, or 3. So suppose I choose equation number 1, substitute y equal to 3 and z equal to 2 into equation number 1. So let's just consider the first equation here. Therefore, I have x, which is minus y. Y is actually 3, z is actually 2. Therefore, I have a negative 9. Then I have x minus, that one is actually 5 equal to a negative 9. X is actually a negative 9 plus with 5. Therefore, I have x, which is equal to negative 4. So now we already solved these equations where we will obtain the value for x, which is actually a negative 4, y, which is given by 3, and z is equal to 2. So we have solved this one. All right. All right. So, but an important thing here is that the idea is to obtain the what do we call the equation, the simultaneous equation in two variables, and but in this case we have reduced to one variable, so we can obtain the value for z directly from this what do we call equation. All right, so this one, in this case we have simplified, all right, the calculation. All right, now let's move to this one. All right, so suppose we have this one, x minus y equal to a negative 1. All right, so firstly let me just label it. All right, because we have the three equations, we need to solve them simultaneously using in three variables, right? So what we do is to reduce into two variables, since equation number 2 here is already in the two variables. So what we need to do is to reduce equation number 1 and equation number 3 so that we can reduce it into two variables. So what we need to do is to have the equation without z, meaning to say that we have to eliminate z from the first and third equation. All right, so that firstly to eliminate z, so but we have the different, what do we call, different coefficient for z in this case, right? So we need to make them to have the same coefficients. Therefore I multiply equation number 1 with 3, right? Equation number 1 multiplied with 3, therefore I have 3x plus 6y plus 6z equal to 18. And for the equation number 3, I multiply with 2, so that I have now 4x plus with 2y plus with 6z equal to 14. Please take note that the coefficient of the z now is actually the same. Therefore, we can now actually minus, right? So let me just write equation number 4 and equation number 5. And then we can subtract equation number 5 from equation number 4. So 4 minus 5 in this case, we have, right, 3x minus 4x, we get negative x. 6y minus 2y, we get 4y. 6z minus 6z, we got 0. And then 18 minus 14, we get 4. Please take note that we obtain equation number 6, and now we need to solve the simultaneous equation in two variables. We consider the equation number 2 here, and also equation number 6. Please take note that now equation number 2 and equation number 6, they have two variables only, in which the variables are x and y. So we can solve them simultaneously, right? So in this case, we try to solve equation number 2 and 6 simultaneously. So let me just write equation number 2, -1. This is equation number 2. Equation number 6 is given by -x plus with 4y equal to 4. This is equation number 6. Therefore, we can solve simultaneous equations. You can use elimination method. So if you want to use elimination method, meaning to say that I just need to add 2 with 6, right? Equation 2 with 6. Therefore, you just add this with x minus -x, we get 0. -y plus with 4y, we get 3y. And -1 plus with 4, we get actually 3. Therefore, y is actually 3 divided by 3, which is 1. So y we obtain as 1. So this is the first solution. Since we obtain the value for y, which is equal to 1, therefore I need to substitute in any of these two equations. Therefore, I just, let's say I substitute, right? Substitute y equal to 1 into the second equation, the second equation. Therefore, I have, right, x minus y is actually 1 equal to -1. Therefore, I have x, which is given by a -1 plus with 1. Therefore, I have x, which is given by 0, right? So we obtain x equal to 0 and y equal to 1. Therefore, I can substitute these values inside either 1 or equation number 3. So either one, all right? So therefore, all right, so let me just write it here. Substitute x equal to 0 and y equal to 1 into equation, let's say I choose equation number 1. So I just need to substitute inside this equation. So I have x is actually 0 and y is actually 1. Therefore, 2 multiplied by 1 plus with 2z equal to 6. Therefore, solving this one, 2 plus with 2z equal to 6. 2z equal to 6 minus 2. Therefore, I have 2z equal to 4. To get a value for z, I have to divide 4 with 2. Therefore, I have z, which is given by 2. So we obtain z is equal to 2. Now we have already obtained the solutions where y equal to 1, x equal to 0, and z is equal to 2. Right? So we are done with the third example here. Let's now move to the last example for this video. If we have this one as the first equation, this one as the second equation, this one as the third equation. If we want to eliminate one of the variables, suppose I choose to eliminate x, for example. If I want to eliminate x, therefore I have, like for example, equation number 2 minus 1. Therefore, I have, alright, 2y minus y will give me y, and 2z minus z will give me a z, and then I have 3 minus 2 will give me 1. Therefore, I obtain the fourth equation. Alright, now if I want to consider this second equation and the third equation, so if I want to eliminate x, I have to make the coefficient the same here. So to make the coefficient the same, therefore I have to multiply equation number 2 with the coefficient 3. Therefore, I have 3x plus with 6y, because I have to multiply each term here with 3. Alright, so I have 6y plus with 6z equal to 9. That is equation number 5. So now I want to consider equation number 5. With equation number 3, I have 3x plus 2y minus z is equal to 8. So this is actually equation number 3. So what I do to eliminate x is actually to subtract equation number 3 from 5. So I have 5 minus 3. Therefore, 3x minus 3x will give me 0. 6y minus 2y will give me 4y. And then 6z minus negative z will give me a positive 7z. Alright, this one is actually equal to 1. So this is equation number 6. Now, I obtain two equations in two variables, which is y and z, right? Which is given by equation number 4 and equation number 6. So what I need to do is to find the value for y and z by solving the simultaneous equations in two variables. So let me just write the simultaneous equations in two variables. So this is given by equation number 4. And alright, this is equation number 4, and this is equation number 6. 4y plus 7z is actually equal to 1, right? This is equation number 6. You can use elimination or substitution. Just in this case, let me just write equation number 7, right? From 4, so it will become 1 minus z. So this is equation number 7. So I substitute 7 into equation number 6, because this one is from 7, so it should be entered into 6. Right, so when I substitute 7 into 6, therefore I have 1 minus z plus 7z. This is actually equal to 1, so I have 4 minus 4z plus with 7z will give me 1. Therefore this one is simplified at 3z equal to 1 minus 4. 3z is equal to a negative 3. Therefore z is actually equal to a negative 1. Right, now I obtain z is equal to negative 1, so I substitute back. Alright, substitute z equal to negative 1 into equation number 7. Alright, so I have obtained the first solution here, z equal to negative 1. The second one should be, alright, when I substitute inside this equation, right, this equation, so I have y, which is given by a 1 minus a negative 1, right? So I have y equal to positive 2. So this is the second solution. So to get a value for x, I can substitute. Let me just substitute y equal to 2 and z equal to a negative 1 into equation number 1. Alright, so here. So I have, alright, so x plus y is actually 2, plus z is actually negative 1, so minus 1, which is given by 2. Therefore, I have, alright, x, which is given by 2 minus 2 plus 1. Therefore, x is actually a positive 1. So I have the third solution for the for this example. Alright, so now I've obtained the value for x, y, and also z. Solving simultaneous equation in 3 variables. Please take note that if we have the equations in 3 variables, meaning to say that we have 3 equations. So of course we have 3 equations. So what we need to do is, from the 3 equations, we need to reduce into 2 equations with only 2 variables. All right, so either we eliminate x, y, or z. We can eliminate one of them. So when we have the 2 equations in 2 variables, so therefore we can solve this. All right, so suppose, let's say you have x, y, and z, right? For example, if you eliminate, when you eliminate z, so of course you get x and y. So when you solve these simultaneous equations for x and y, you get a value of x and you get a value for y. Therefore, you can substitute back into either one of these equations to get the value for z. So we obtain the value for x, y, and also z. All right, so that's it. Thank you for watching this video. See you in the next chapter.